Hi there, my name is Mitch Karlabidis, and in this video, which is actually one of our videos on a series of videos on transformations, we will work together some exercises. Let's go directly on describing worked exercises on graph transformations. So let's start with the first one. Let the function f of x, where x goes from 0 up to 15, and the point with coordinates 4, -5 lies on the graph of f. Which point will be on the graph of f of, let's put that, 3 f of x minus 4. Okay, here we need to have a plan. We were given a function f of x, and we were told that this transforms to 3 f of x minus 4. Point 4, -5 lies on the graph of f, and we want to see where will it move. At first, I need to describe this. I need to describe it. F of x. At first, I will create the 3 f of x, which is a vertical. Sorry, let me do that here. From f of x, I should firstly create the 3 f of x. And this is a vertical dilation of factor 3. This, however, since we know that every description can be seen as a set of instructions, vertical means on the y. Dilation, multiply the y of a random xy point, multiply just the y coordinate by 3. So the xy would have turned at x 3y. Then it's time for us to include the minus 4, which is a vertical translation 4 units downwards, which means that to our most updated point, which had coordinates x and 3y, we should take out 4 from its y coordinate, from 3y, which leads to x, 3y minus 4. Overall, under this transformation, we just proved that the random point xy will move to x, 3y minus 4, which means that if we apply this to the given point with coordinates 4 and -5, this should go to 4 and 3 times -5 minus 4, which is 4, -15 minus 4, which in the end is 4, -19. So this is a typical exercise in which a transformation is described, is given basically. A point on the initial graph is given, and we are asked to find the new corresponding coordinates on the new graph. We have to do the description, and based on the description, apply the instructions on the coordinates of the random point x, y. Let's see a second example. Let me see here a second example. Similar to that, which says the table x f of x with values 0, 1, 1, 5, and 3, 6 gives values for a function f, which table could then be created for g of x equals f of x plus 1 minus 2. Again, it's not pretty much, it's exactly the same exercise as before. We are given a transformation. We know that from f of x, we are moving to f of x plus 1 minus 2. We're given not 1, like before, but 3 points on the graph of f, the points with coordinates 0, 1, 1, 5, 3, 6, and we are asked to basically find the new corresponding points. To do so, we need to do the description first. So, starting from f of x, I would say, we have seen in a video that the order in this case doesn't change a thing. I would have done the f of x plus 1, which is a horizontal translation of 1 unit to the left, which means that starting from the random point with coordinates x, y, I should, horizontal translation 1 to the left means that I should take out 1 from just the x. So x minus 1, y. That is then followed by a vertical translation of 2 units downwards. So that should be x minus 1, y minus 2. And this means that I just managed to express x, y as x minus 1, y minus 2, not express x, y to that. I found the connection from x, y to the new coordinates. Now I'll apply that for each one of my original points. 0, 1 would move to 0 minus 1, 1 minus 2, which is negative 1, negative 1. 1, 5 would move to 1 minus 1, 5 minus 2, which leads to 0, 3. 3, 6 will move to 3 minus 1, 6 minus 2, which is 2, 4. So the new table of values would be x, and g of x would be negative 1, negative 1, 0, 3, 2, and 4. Let's see a third example. Let the following graph of f of x, and let this graph be this. And let that be it. And we know that this is the point with coordinates, let's say negative 2, 5. This would have been the 1, 5, this could be the, let's say, 2, 1. And this could be, let's say, 3, 4. On the same set, on the same set of axes, draw h of x is f of x minus 1 plus 3. Again, similar to the previous exercises. In order to draw a new graph, we need to realize the following, that when a graph is transformed, every single point on that graph is also transformed, and not randomly, it also follows the description mentioned. So, at first, we need to see the description. In order to go from f of x to f of x minus 1 plus 3, I should do a horizontal translation of 1 unit to the right, which is then followed by a vertical translation of 3 units up. Considering the coordinates of these points, starting from the point with coordinates x, y, the horizontal translation 1 unit to the right will give me the x plus 1, y. Then the vertical translation of 3 units up will create the x plus 1, y plus 3. Now I need to properly apply these transformations on each one of the graphs that can be seen. You will be able to see them on a real set of axes. I simply created them here. We need to apply these transformations, these changes, on any of these points. So the minus 2.5, minus 2,5, will move at minus 2 plus 1, 5 plus 3, which is the minus 1, 8. The 1,5 will move at 1 plus 1, 5 plus 3, which is 2, 8. The 2, 1 will move at 2 plus 1, 1 plus 3, which is 3, 4. The 3, 4 will move at 3 plus 1, 4 plus 3, which is 4, 7. I need to draw the new graph, which means that I need to use every single one of these points. I should plot them on the same set of axes, and then I will connect them properly. So minus 1, 8, that could be minus 1. Here we could have minus 1, 8. 2, 8 means that it could be this. This could have been 2, 8. 3, 4 could have been the same thing. 4, 7, 4, 7 would have been that. And now I'm properly connecting them. That would have been the new graph, which is actually, it seems, it's evident that the new graph, since here we're talking about translations, but in general, the same process could be applied for any transformation. In this case, that graph moved 1 to the right and then 3 upwards. Let's go to a fourth exercise. This time, this exercise will also include domains and ranges, but only they put them there to trick us. Let a function f with domain minus 1, 2, and range 1, 7. A new function g is given by g of x is minus 3f of x plus 1 minus 2. Find the domain and range of G. Okay, let's see how this can be done. First of all, oh, sorry about that. First of all, I should describe that from f of x, in order to go to minus 3 f of x plus 1 minus 2, I should do the following. First of all, I will create the f of x plus 1, which is a horizontal translation, 1 unit to the left. Then I will create the 3 times f of x plus 1, which is a vertical dilation of factor 3. Then I'll do the reflection. A reflection on x-axis. And finally, I'll take out 2 from the entire thing, which means a vertical translation 2 units downwards. Now, with regards to the coordinates of the points, starting from x, y, the horizontal translation 1 to the left means go and replace x by x plus 1. Not 1 to the left, sorry, it should go x minus 1, comma y. Then vertically dilate by factor 3 means multiply the latest y coordinate by 3. So that should be x comma 1, 3y. Then reflect on the x-axis means multiply the latest y by negative 1. So x minus 1, negative 3y. And then take out 2 from the most updated output. The most updated output is the negative 3y, so I should express it as minus 3y minus 2. I need the domain. The domain is the set of inputs. My inputs here are of the form x comma 1. I need to know the values within the x's lie. The original domain of f was minus 1 comma 2. Originally, the minus 1 comma 2 meant that x was between negative 1 and 2. But now I have x minus 1. In order to create that, I should take out 1 from both of them. So it should be negative 2, x minus 1, and 1, which means that the new domain is basically this, minus 2 and 1. Similar for the range, it's about outputs. The outputs in this case are of the form minus 3y minus 2. Since y originally was between 1 and 7, this meant that y's were greater or equal than 1 and smaller or equal than 7. Now I need to recreate all that. I'll create first the negative 3y. Since I multiplied by something negative, the order should change. It should be like that. Now I should take out 2. minus 3y minus 2, minus 21 minus 2, minus 3 minus 2. So that should be negative 5, negative 3y minus 2, bigger or equal than negative 23, which means that my outputs should be from negative 23 up to negative 5, which means that this should be the range. And a last and final exercise, we are given a description and we need to bring out by ourselves the notation. Let a function f of x. The graph of a new function g is the result of dilating graph of f vertically by a factor of 5, then horizontally by a factor of 2, then translating it by 5, or not, let's make it by 6 units down, and then by 4 units right. Define G. It's not as hard as it seems. I'm not even sure whether it seems hard, but let's see. In baby small steps, we will start, let's say, from f of x, and let's highlight its new transformation. At first, we have dilation vertically by a factor of 5. We should know by now that vertical dilation by factor of 5 means multiply, that's what dilation stands for, vertical, the entire output, so the entire f of x, by 5. So theoretically, that should create the 5f of x. Then let's change color. Horizontally dilated by factor of 2. Horizontal dilation means that, again, we should multiply. That's what dilation stands for. But this time we should do that horizontally, so the multiplication should be seen within the brackets. But all horizontals act like compositions. So we should go in the latest version of our thing, of 5f of x, and instead of x, we should see a factor of 2. But remember that we have this ahat. All horizontals are trolling. We shouldn't be able to see the 2, the actual factor, but rather we should be able to see its reciprocal. So we should be able to see 1/2 of that. So go in x and substitute that by 1/2 x. So far we should be seeing that. Then this most updated form was translated by 6 units down. Translation down means take out vertically from the entire thing. So from the latest version, which was 5f of 1/2 x, take out 6. Let's color that. And finally, 4 units to the right. So 4 units to the right, we should be able to see the opposite. So we should be able to see the x minus 4. It's a horizontal, so it should work as a composition. We should go to the latest version, to the most updated one, which is that, the blue one. And instead of x, we should place x minus 4. Finally, my answer is 5f of 1/2 x minus 4 minus 6. That would be all. That's the kind of questions that one should expect to see, should weigh in the exams. I hope you do understand them. Please, 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 again, if you don't, if there's something that needs more clarification, if there's something that puzzles you, leave your comment below the video. As always, thank you, really thank you for your time.